Okay, I'm going to try to make this video shorter than yesterday. Sorry that was 20 minutes long. And make sure that you are actually watching the video yourself and you are not, well, if you weren't watching the video, you wouldn't hear me say this, but that's okay. Just don't send your notes to other people. Tell them to watch the videos. I can tell who's actually watched them and who's just copied stuff down. Some of you would not have gotten questions wrong on that last assignment if you actually watched the video. I can also see how many views it has had because, you know, it's YouTube and it keeps up with that kind of stuff. So when I have 60 students and only 25 people have seen it, but you've all turned in your notes, that means that some people are just taking the easy road and not actually listening to what I have to say. So I do say some things that I don't write down, so it's important for you to do that. Alright, off my soapbox, and we're doing 11.2. So 11.2 is our second conic section. We did parabolas last time. This will be our ellipses. Okay? And an ellipse is, yes, in English, that is your dot, 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 but it also is a shape that you can get if you slice a cone in the right way. So an ellipse, you might have just thought of this as an oval, but it's not quite oval shaped exactly. It has its own shape. But this is an example of one, and we're going to label all the parts, and I'll tell you how we can get that in a second and have another nice little animation. So we can have horizontal ellipses or vertical ones. It's just essentially a circle that has been elongated, so that looks horrible, but pretend like that's an actual pretty shape there. There's a distance in the vertical direction and a distance in the horizontal direction, and they don't necessarily have to be the exact same distance. If they were the same both ways, that would end up being a circle. So we've got two axes that we talk about. We talk about the major one and the minor one. Obviously the major axis is the longer one. The minor axis is the shorter one. Alright. Let's see what else we've got. These are called vertices. If they are on the major axis, those are our vertices. The minor axis, those are the co-vertices. So from your major axis, that's the longer one, you've got your vertices. On the minor axis, that is the shorter one. Those are your co-vertices. And if you're asked for the length of the major axis, you just see how far it is from vertex to vertex. The length of the minor axis is the distance from vertex to vertex on the minor axis. So obviously with this horizontal ellipse, our major is in the x direction, minor is in the y direction. But if it was swapped, it would be the other way if we had a vertical ellipse instead. You do have foci in this, just like we had for the parabola. Parabola was singular, it was one focus. And an ellipse, there are two of them. So I'm going to label them. This would be F1 and F2. This is actually how we get the shape of an ellipse with these 2 points. Our focus 1 and our focus 2 are foci, as the plural is for focus, it's foci. What an ellipse actually is it is all of the points that when you add up the distance from F1 and F2 to those points, it's going to give you twice the length of the major axis. So a lot of times with the major axis, we call these like negative A and A there. So this will make a little bit more sense than when I draw a picture. So if I've got this and this length plus this length is going to equal 2 times one of those sides, or the entire minor axis. So I could also do it all the way around. So from here to here to here, that's going to be the same length as the, did I say minor a second ago? It's going to be major axis. The exact same length as the major axis. You see it a lot when you get to this point. So here to there, to this, and then that. That's the exact same length as our major axis. So that's how you can actually get the ellipse. So you could take 2 points and you have the same distance from there to the exterior back down to F2 all the way around. So I'm going to show you a little picture of how you could draw an ellipse on your own, getting that. So here's an animation. Sorry, you can get that out of there. You can kind of see that they just take it and just kind of just like pulling it tight. Here are your 2 foci. There we go. There we go, all the way around, and it's going to make an ellipse like that. Okay? So we don't have to get too bogged down on how that all comes about when we're actually drawing the ellipses ourselves from our equations. Our equations are really easy to understand and do. I know that's a little bit complex in terms of what it actually is and how we get those points. But our equations are as follows. Okay? So it's very similar to the equation of a circle, which is x squared plus y squared equals r squared, because this is like a variation of a circle, but it goes like this. X squared over a squared plus y squared over b squared is equal to 1. Okay? And this would be for a horizontal ellipse rather than a vertical ellipse, because the A is normally from your major axis. Look like that. The A and the minor axis, that's when we're talking about our B. So this is our bigger number. So if you have the bigger number under the X, you're going to end up with a horizontal ellipse. If your larger number is underneath the Y, you'll end up with a vertical ellipse instead. Alright? So I'm just going to show you how to graph it, and then we'll write down what all of our different things are, and then we'll figure out how to find our focus and do some transformations, and that will be it for this. So that's our base equation. So I'll erase this and show you just how quick and simple it is to make these ellipses. So x squared over 36 plus y squared over 16 is equal to 1. So I'm going to look underneath and see which one's larger. So it looks like the one underneath the x is larger, so I know my ellipse is going to be horizontal. And I see 36 is the same thing as 6 squared. 16 is the same thing as 4 squared. So that means I'm going to go 6 in either direction, in the x direction, 4 either way in the y direction, and draw my ellipse. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 1, 2, 3, 4. Put my points. 1. And then draw it. Okay? So that's how you would draw that. You just look underneath the x. Okay, that's 6 squared, so I go 6 in either direction. That corresponds with our A. This would be from our negative A, negative B, positive B. And there you have it. So we'll see, we can write down what our vertices are. So our vertices are the ordered pairs negative 6, 0, and 6, 0. Our co-vertices are 0, 4, and 0, negative 4. What's the length of the major axis? The major axis is the longer one, so the major, and its length from end to end is going to be 12. There's 6 on either side. And then the minor one, y'all already can tell, the minor length is going to be 8. Okay? And we haven't figured out where our foci need to be in this particular problem. So if we go back up to our picture of, I'll show you how to figure out your equation of your foci and the equation that we use for that. Okay? Alright, so this distance is B, right? This distance, we're going to call it C from the origin to our foci. That's going to be helpful for us. And if we think about our line drawn like this, okay? we're going to pull that all the way. If we had like a string or something, we're going to pull that all the way up to B, to where this is C, this is B, and then this length, remember that this length in total was 2 times A. I said that earlier. So half of it is just going to be A by itself. So if we just draw a triangle over to the side and just write down what those are, this is C, this is B, and this is A. Okay? The right triangle. So if we want to figure out what C is, we'll just use the Pythagorean theorem. So B squared from our minor plus C squared is equal to A squared. So A squared, the A is from our major axis, B is from the minor axis, and C would be our focal, our distance here from the origin to our foci. So if you want to solve for C, you would just subtract the B squared. So C squared is just A squared minus B squared, and then we'll solve for C. So we'll do that over here. So our A value was 6, B value was 4, and we're trying to find the C. So to find our foci, C squared is 6 squared minus 4 squared, 36 minus 16, and that is 20. So C squared is 20, so C is the square root of 20. We need to break that down if we can. Just 4 times 5, so 2 root 5. So our foci is 2 root 5 away from our center on either side. It's always on your major axis. So the square root of 20 is between 4 and 5, right? So that is between 4 and 5. So I'm just going to put it here and put it right there. And if we have to write our ordered pairs down, our ordered pairs for our foci are going to be 2 root 5, 0, and negative 2 root 5, 0. Okay? Alright, we're going to do one more where it's centered at the origin, and then we'll do a transformation kind, just for us to practice. This is going to be a shorter video, we'll see. Alright, so now let's go with a vertical one, just so we can kind of see. Let's say I had x squared over 9 plus y squared over 25 equals 1. So 9 is 3 squared, 25 is 5 squared. So I need to go 5, 5, 3, 3, put my points, okay, so I can write all my stuff down. My vertices are on my major axis, so that's 0, 5, and 0, negative 5. My co-vertices on my minor axis, so 3, 0, negative 3, 0. The distance of the major is 10. The minor is 6. And then for my foci, C squared is A squared minus B squared. In this case, our A is the coming from our 25 instead of coming from the first one, because the longer one was underneath the Y, so that corresponds to your A. A is always on the major axis. So that's going to be 5 squared minus 3 squared, which is 25 minus 9, and that is 16. The square root of 16 is 4, so our C is 4. So 4 away from the origin on your major axis. So 4 away, 4 away. So our foci, those ordered pairs, are negative 4, not negative 4, 0, negative 4, and 0, 4. Alright, I think y'all are probably ready for a transformation one, so we'll give it a go. Transformation's just like before. With your parabola, if it's with the x, it's left or right. If it's with a y, it is up or down. just do one transformation example, and I think that should be enough. Say I had x plus 2 squared over, let's do 4, and then plus y minus 3 squared over, I don't know, what's a good perfect square? Did we already do 36? What about 49? 49 is good. And that equals 1. So before we talk about how far it is, left and right, whatever, we need to think about the shifts. It's with the x, we're moving to the left or right. Positive means we go left 2. It's with the y, it's up or down. We're always going to go opposite when we are in parentheses like this. So this is going to go up 3. So we go left 2, up 3. And then we see about our squares. So 4 is 2 squared, and 49 is 7 squared. 1, 2, 3. I'm going to start with my center. My center is now going to be at negative 2, 3. And I'm going to have to go 7 up and down. That wasn't smart. I'm going to run out of space. And then I'm going to go 2 left and right. Okay. So 1, 2. I got the 2. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So left and right is 2 because that's underneath the x. Up and down is 7. And here we go. Obviously this is not to scale. It looks like a, I don't know what that looks like. And we can write all of our stuff down. Vertices on the major axis are going to be 2. How far is this? That was at 3, and then I went 7 more, so 10. And the other one is going to be at 2, 3, and then so negative 4. Our co-vertices are, let's see, 0, 3, and 4, 3. The length of the major axis is 14. The minor axis is 4. And then I want to figure out what my c value is for my foci. So c squared is a squared minus b squared, which is 7 squared minus 2 squared. 7 squared minus 2 squared. That's 49 minus 4, which is 45. So c squared is the square root of 45, which is 3 root 5. Okay. So I'm the square root of 45 away from this center point going up and going down. So the square root of 45 is in between 6 and 7. So it's almost 7 units away. It's closer to 7 than it is to 6. So I'm going to go 1, 2, 3, 4, 5, 6 and a little bit. Okay. And then 3, 4, 5, 6 and a little bit. So those are my foci. And I've got to figure out what those ordered pairs would be. So my x value is still going to be 2. And my y value, I was at 3, and then I went up 3 root 5. So it's going to be 3 plus 3 root 5. Because I went up that much, that's that distance for my first ordered pair. Then my second ordered pair, the y value is still 2. But then I was at 3, and I went down 3 root 5. So those will be my foci for that problem. Alright. You will have to write some equations. You'll be given like vertices or given foci, and you'll have to figure out what that is, but I think that y'all can do that. Whenever they give me that stuff, I always just sketch it and see what it's going to look like and determine if it needs to be, what needs to go where, what needs to go underneath the x squared or the y squared. If it's a horizontal one, your bigger number will be underneath the x squared. Vertical one, your larger number will be underneath the y squared. Alright, and so if you didn't write the formula to find the focus, that's at the top. you might want to put that underneath your equations just so you can have it. So c squared is a squared minus b squared. That's to figure out what your c is for your distance for your focus. Alright, I hope that wasn't super confusing. I really like doing these graphs. They were some of my favorite graphs to actually make because they're not really that hard once you get the hang of how it shifts and how it moves and things. But if you have any questions, just let me know and I'll be happy to answer them for you. Have a good day.